Hey everyone, and welcome back to the Deep Dive. Today we're going to be taking a deep dive into something that I think is so fascinating. Human origins and ancestry.
Oh, yeah.
We're going to be covering everything from like the emergence of Homo sapiens to, those DNA tests that everyone's talking about these days. And, if the word genomics is kind of intimidating you, don't worry, we're going to break it all down.
Yeah.
And make it exciting. And hopefully you'll discover some really cool things about,
Absolutely.
your connections to the past.
That's what's so cool about genomics.
Yeah.
It's like a time machine to look back at our ancestors and to understand how they shaped who we are today.
Okay, so maybe let's just start with the basics.
Okay.
For those of us who haven't been brushing up on our genetics lately, what is genomics?
So genomics is basically the study of all the genes that make up an organism. So think of it as the instruction manual for life.
Okay.
And with new technology, we can read that manual never before.
So it's not just like,
No.
digging up old bones anymore.
Not at all.
Oh, wow.
Genomics allows us to go way beyond fossils and artifacts. We can analyze DNA from ancient remains, even soil samples.
Wow.
And it helps us trace human migration patterns, understand how different populations adapted to their environments, and even discover connections between modern humans and our extinct relatives.
My mind is already blown. So we're talking about like tracing our lineage back thousands of years.
Thousands.
Yeah.
Try hundreds of thousands.
Oh, wow.
The story starts in Africa.
Okay.
The cradle of humanity.
Yeah.
The oldest Homo sapien fossils, like the Homo kibish remains found in Ethiopia, date back around 200,000 years.
Wow.
And the fascinating thing is all modern humans can trace their ancestry back to a common ancestor who lived in Africa.
Wow.
We're all part of one big extended family.
That's incredible. Yeah. So how did we end up like scattered across the globe?
Right.
If everyone originally came from Africa?
Yeah, that's a great question.
Did our ancestors just get like wanderlust or something?
Well, let's just say they were incredibly adventurous.
Okay.
Around 60,000 to 70,000 years ago, groups of Homo sapiens started venturing out of Africa.
Yeah.
They migrated across continents, facing incredible challenges, and adapting to diverse environments along the way.
So like an epic journey.
It was an epic journey.
Where did they go first?
So imagine this.
Okay.
Some groups traveled south, following the coastlines of Asia.
Wow.
Eventually reaching Australia.
Wow.
Can you imagine navigating by the stars and using simple boats to cross vast stretches of water?
Honestly, I get nervous taking a ferry to the nearby island.
Right.
That's crazy.
It's incredible to think about the courage and resilience of these early explorers.
Totally.
Other groups took a northern route, moving through this narrow passageway called the Bab el-Mandeb Strait, which connects the Red Sea to the Indian Ocean.
Okay.
From there, they spread throughout Asia, Europe, and eventually even crossed over into the Americas.
Okay, so they're spreading out all over the globe.
Yeah.
Do they just like run into vast empty spaces, or?
That's a good question.
Were there other, like weren't Neanderthals like
yes, you're right,
roaming around Europe at the time?
The world wasn't exactly empty.
Okay.
As Homo sapiens spread out, they encountered other hominin species like Neanderthals in Europe and Denisovans in Asia. And get this, they didn't just coexist. They interbred.
Wait, seriously?
Yes.
So I could have a little bit of Neanderthal in me.
You very well might.
I knew there was a reason I wasn't a morning person. So
most people of non-African descent carry about 1-2% Neanderthal DNA in their genomes.
Wow.
And those Neanderthal genes might still be influencing certain traits today, from immune systems to, even our sleep patterns.
So I'm blaming my night owl tendencies, my Neanderthal ancestors.
It's possible.
But what about other traits? Like, did Neanderthals have red hair, for example?
Actually, that's one trait they likely didn't have.
Oh.
Studies have shown that the genetic variations responsible for red hair were extremely rare or absent in Neanderthals.
Oh, wow.
So it seems red hair is a uniquely human trait.
All right. Neanderthals, you can keep the night owl gene. But we're keeping the red hair.
Fair enough. But it's not just about inheriting specific traits. These ancient encounters highlight the incredible complexity of human evolution.
Yeah.
We're not just the product of one lineage.
Right.
We're a mosaic of different hominin groups that interacted and interbred over millennia.
That's fascinating. It's like piecing together this giant puzzle.
It is.
With each piece representing a different chapter in human history.
Exactly.
So while they're migrating and encountering other groups, how are these early humans adapting to all these different environments?
That's where we see some of the most remarkable adaptations in human history.
Okay.
From skin color and hair type to unique cultural practices and technologies. Our ancestors were constantly evolving to survive and thrive in diverse conditions.
Give us some examples. I bet they invented some pretty cool stuff along the way.
They did. Take the Cro-Magnon people in Europe, for example.
Okay.
They lived around 40,000 years ago.
Okay.
Developed sophisticated tools. Created stunning cave art.
Oh, wow.
And even used symbolic representations.
Wow.
They were the artists and innovators of their time.
So like the prehistoric Picassos.
Exactly.
What about other parts of the world?
Well, early Asian populations faced a whole different set of challenges.
Yeah.
From the frigid Siberian steppes to the lush tropical forests.
Wow.
They developed incredibly diverse technologies and ways of life to adapt to these extremes.
Yeah.
Imagine living in a world without supermarkets.
Right.
Relying solely on your knowledge of the land and your ability to craft tools for hunting and gathering.
It's mind-blowing to think about the resourcefulness of these early humans.
Yeah.
And what about Australia? Didn't Aboriginal Australians arrive there quite a while ago?
They did. Aboriginal Australians reached the continent around 50,000 years ago and thrived in its diverse and often challenging landscapes for a millennia.
Wow.
Their deep understanding of the land, their unique cultural practices, and their complex social structures are a testament to human resilience and adaptability.
This is all so incredible.
Yep.
It really paints a picture of our ancestors as these incredible explorers and survivors and innovators.
Absolutely.
But wait, what about the Americas? How did people get there?
Right.
They couldn't have walked, could they?
That's where things get really interesting.
Okay.
We need to go back to the last ice age.
Okay.
About 15,000 to 20,000 years ago.
Okay.
Lower sea levels exposed a land bridge called Beringia, connecting Siberia and Alaska.
Right.
This bridge allowed our ancestors to walk from Asia into North America.
What, they literally walked across like a frozen ocean.
Pretty much.
That's both terrifying and amazing.
I know.
What kind of evidence do we have of these early Americans?
One of the most well-known early American cultures is the Clovis culture, dating back about 13,000 years.
Wow.
Archaeologists have discovered their distinctive stone tools, especially those beautifully crafted spear points throughout North America.
Wow.
It's amazing to think that those points were once used to hunt.
Yeah.
Now extinct megafauna like mammoths and mastodons?
Okay, I am officially in awe of our ancestors.
I know, right?
But all this movement and adaptation, it must have led to incredible genetic diversity, right?
Absolutely. The genetic diversity we see in modern humans is a direct result of these epic journeys and encounters.
Yeah.
It's like a tapestry woven from the threads of our ancestors' experiences, from the vast array of skin tones and hair types to unique genetic adaptations that help us thrive in different climates and resist diseases.
Yeah.
It's all written in our DNA.
It's amazing to think about how our genes hold the stories.
They do.
Of our ancestors. But there's more to the story. I've heard about genetic bottlenecks.
You're right.
And how scientists are actually extracting DNA from ancient remains.
You're right. There are so many more layers to this story.
Yeah.
And they're hidden within something so tiny, yet so powerful.
Ancient DNA. We'll delve into that fascinating world.
Right.
And the personal side of genomics with the rise of ancestry testing.
Oh, yeah.
In the next part of our deep dive.
Okay.
Stay tuned.
I can't wait. This is already blowing my mind.
No, it's so cool.
Yeah. It's incredible.
Yeah. Welcome back to our deep dive into human origins and ancestry. Before the break, we were talking about those incredible journeys our ancestors took, adapting to new environments and even encountering other hominin groups like Neanderthals. But those encounters, those journeys, they left more than just footprints. They left traces within our very DNA, and that's where ancient DNA analysis comes in.
Okay, this is what I've been waiting for. I find it so fascinating that scientists can extract DNA from ancient bones and even soil samples. It's like having a direct line to the past.
It really is. Ancient DNA analysis has completely revolutionized our understanding of human history. It's like having a key that unlocks hidden chapters in our collective story.
So how does it work? Do scientists just wave a magic wand over a fossil and poof, ancient DNA appears?
Yeah, I wish it were that easy. It's a meticulous process, but it's pretty amazing. Scientists use incredibly sensitive techniques to extract tiny fragments of DNA from ancient remains. We're talking bones, teeth, hair, even those soil samples you mentioned.
Right.
And then using advanced sequencing technologies, they piece those fragments together like a giant jigsaw puzzle, creating a genetic snapshot of the past.
That's incredible. So we're not just speculating about what happened thousands of years ago. We're actually reading the genetic code of our ancestors. What kind of secrets has this ancient DNA revealed?
Well, remember how we were talking about Neanderthals and how most people of non-African descent carry some of their DNA? Ancient DNA analysis has not only confirmed that interbreeding occurred, but it's helped us pinpoint where and when those encounters happened. We can trace the movement of different groups and understand how they interacted over time.
So it's not just about confirming what we already suspected. It's adding a whole new level of detail and nuance to the story.
Yeah, exactly. And sometimes it leads to completely unexpected discoveries. For instance, ancient DNA analysis revealed the existence of a whole new hominin group, the Denisovans.
Wait, hold on. A whole new group of ancient humans. How did they miss that before?
It all started with a tiny finger bone and a few teeth discovered in a cave in Siberia. When scientists analyzed the DNA from those remains, they realized it didn't match up with Neanderthals or Homo sapiens. It belonged to a distinct lineage, a group we now call the Denisovans.
That's amazing.
Yeah.
So ancient DNA isn't just about confirming what we already know. It's leading to completely new discoveries about our past.
Yeah.
But how does all this relate to us today? Does it have any practical implications?
That's a great question, and the answer is a resounding yes. Uncovering the mysteries of our past is fascinating in its own right, but ancient DNA analysis also has implications for understanding modern human health and disease.
Really? How so?
For example, those Neanderthal genes that we talked about earlier, well, they might actually influence our susceptibility to certain diseases or even our response to medications. By studying the genetic legacy of our ancient ancestors, we can glean valuable insights into our own health.
Wow. So ancient DNA analysis isn't just about dusty old bones. It's a powerful tool for understanding ourselves in the present.
It is. It's a bridge between the past and the present, connecting us to our ancestors in ways we never thought possible. But there's another side to this story, a more personal side that's captivating people around the world. Ancestry testing.
Yes. Those at-home DNA kits are everywhere these days. I even gave one to my mom last year for her birthday. But what can these tests really tell us about our ancestry?
Commercial ancestry tests analyze your DNA and compare it to reference databases containing genetic information from people all over the world. By identifying shared genetic markers, they can estimate your ancestral origins, tracing your lineage back to different regions, and even specific populations.
So it's like a genetic family tree.
In a way, yes. But it's important to remember that these tests provide estimates, not absolute truths. The accuracy and detail of the results can vary depending on the company, the size of their database, and the specific populations they cover.
I've heard some tests are more accurate than others, but even with limitations, people are really drawn to these tests. What do you think that is?
I think it taps into a fundamental human desire, a longing to understand where we come from, to connect with our past and our ancestors. Ancestry tests offer a tangible way to explore those connections, to uncover hidden chapters in our family history, and even to connect with unexpected relatives.
I can definitely see the appeal. It's like holding a piece of your personal history in your hands. But aren't there potential downsides to ancestry testing?
You bring up an important point. While these tests can be incredibly insightful, it's crucial to approach them with a realistic understanding of their limitations and potential emotional impact.
What do you mean by emotional impact? Can finding out about your ancestry be that upsetting?
For some people, it can be. Unexpected discoveries can challenge deeply held beliefs about family history or personal identity. Imagine finding out that your biological father isn't who you thought he was, or uncovering a family secret that was intentionally kept hidden. These revelations can be incredibly difficult to process.
That's a good point. It seems like ancestry testing can open up a Pandora's box of emotions, but it can also lead to some truly heartwarming discoveries, right?
Absolutely. There are countless stories of people using ancestry tests to connect with birth parents or siblings they never knew they had. It's remarkable how these tests can bring families together and provide a sense of belonging and closure.
So it's a powerful tool, but one that should be approached with caution and realistic expectations. It seems like the more we learn about our ancestry, the more complex it becomes.
You hit the nail on the head. It's not just about tracing our family tree. It's about understanding our shared human story, the incredible journey that brought us to where we are today, and the responsibility we have as we continue to unlock the secrets of our past and shape our future.
This conversation has been so eye-opening. I'm starting to realize how much more there is to learn about our origins and how it all connects to who we are today. But there's one more thing I'm curious about. What about the ethical considerations surrounding all of this?
That's an incredibly important point, and one we'll delve into in the final part of our deep dive. We'll explore the power and responsibility that comes with this knowledge and how we can ensure genomics benefits humanity while protecting individual rights and privacy. Stay with us.
Welcome back to the deep dive. We've been on this incredible journey exploring human origins and ancestry. From those early Homo sapiens in Africa taking those epic migrations across the globe, encountering Neanderthals along the way, and we even dove into ancient DNA analysis. And then last time we got really personal, exploring those ancestry tests that are so popular right now, uncovering those exciting discoveries, but also, the potential complications that can come up.
It really has been quite a journey. And through it all, we've seen how genomics has revolutionized how we understand the past, how it connects us to our ancestors, and brings up all these really important questions about how we use this knowledge, questions that we should tackle now.
You're right. We touched on those ethical considerations surrounding genomics, and I think it's really important to explore them more deeply. The more we learn about our ancestry and the power of all this technology, the more critical it feels to discuss responsible use.
I couldn't agree more. Genomics gives us this window into incredibly personal and sensitive information, not just about ourselves, but about our families and our ancestors. This knowledge has incredible potential for good, like helping us understand diseases, personalize healthcare, and even connect families. But as with any powerful tool, there's always that potential for misuse.
So let's talk about that potential for misuse. What are some of the ethical concerns around genomics?
Well, one of the biggest concerns is privacy. Our DNA holds a wealth of information about us, and as this technology becomes more accessible, we need to really prioritize protecting that information from being misused.
So we're talking about safeguards to make sure that our genetic information isn't accessed or used without our consent.
Exactly. Strong regulations and policies are crucial to protect individual privacy and prevent discrimination based on genetic information. Imagine a world where employers or insurance companies could access your DNA and make decisions based on your genetic predispositions. It's a scenario we definitely want to avoid.
That's a scary thought. It feels like something out of a dystopian novel. Are there any other concerns beyond privacy?
Definitely. Another significant ethical consideration is genetic engineering. The more we learn about how our genes work, the closer we get to being able to manipulate them, to potentially edit out diseases or even enhance certain traits.
That sounds like science fiction. Is that even possible?
It's becoming more possible every day, and that's exactly why we need to have these conversations now. Establishing clear ethical guidelines and regulations around gene editing is essential, making sure that it's used responsibly and doesn't worsen existing inequalities.
That makes sense. It's crucial to think about the potential consequences of these powerful technologies, but it also sounds like genomics holds incredible promise for improving human health.
It absolutely does. Imagine a future where medicine is tailored to your unique genetic makeup, where treatments are more effective and have fewer side effects.
So we're talking about personalized medicine. That's incredible.
It is. Genomics is already being used to develop targeted cancer therapies and identify individuals who are at higher risk for certain diseases. That knowledge allows for earlier intervention and preventive measures, potentially saving lives and improving health outcomes.
Wow. So the future of healthcare could be incredibly personalized thanks to genomics. It's amazing to think about the possibilities, but it also feels like there's a lot at stake. How can we make sure these technologies are used ethically and for the benefit of all humanity?
That's the million-dollar question, isn't it? It requires a multifaceted approach. We need open dialogue, education, and robust regulations. It's about scientists, Policymakers, ethicists, and everyday citizens coming together to shape the future of genomics, ensuring it benefits everyone.
So what can we as individuals do to be part of this conversation and make sure that genomics is used responsibly?
That's a great question. Start by staying informed about the advancements in genomics and the ethical issues surrounding its use. Have those discussions with your family, friends, and community. Support organizations working to promote the ethical and equitable use of genetic technologies. And advocate for policies that protect privacy and prevent discrimination based on genetic information. Every voice truly matters in this conversation.
Well said. This has been such a fascinating and thought-provoking deep dive. We've explored our ancient past, delved into the complexities of our DNA, and really contemplated the future of genomics and its ethical implications. What an incredible journey it's been.
It really has. And this is just the beginning. There's so much more to discover about human origins, ancestry, and the power of genomics. As technology advances, we can expect even more exciting discoveries, challenges, and opportunities.
To our listeners, thank you so much for joining us on this incredible exploration. We hope this deep dive sparked your curiosity and inspired you to continue learning about this fascinating and ever-evolving field.
If you're interested in learning more, be sure to check out the resources we've listed in the episode notes. And remember, this journey doesn't end here. Keep exploring, keep questioning, and keep diving deeper into the mysteries of our shared human story.